Okay, so last week we talked about how probability, the definition of probability is the probability of any event. Let me write this down here. Let's say the probability of any event A is going to be the number of favorable over total outcomes. That was our notes from last Friday and Thursday. Gentlemen in the back, Marin and Moreno, I got the floor here. Thank you. Favorable outcomes, in other words, what am I looking for over a number of total outcomes? What I'm going to do is I'm going to give my final calculation as a fraction, a decimal, and as a percent. This class needs to know that you can express a probability in any three forms. In other words, you'll be held responsible next Friday's quiz, which will have probability. You have to be able to tell me the probability in any of those three forms. So the fraction, let's see, we have 3 dimes and a quarter. The probability of getting a dime is, as a fraction, will be 3 out of 4. 3 out of 4 reduced? Yeah, it's reduced. You can't reduce 3/4 anymore. In other words, if you can reduce a fraction, do it. Okay, how about a decimal? To make a fraction a decimal, just do exactly what the fraction says to do. In other words, watch this. I got my calculator up here. 3 divided by 4, 0.75. So in fraction form, or decimal form, it's 0.75. And then percent, all you got to do is look at this decimal. This is the hundreds place at 5. So this really means 75%, 75 out of 100, because we learned in week 1 that a percent is any fraction out of 100. So if this is the hundreds place, that means 75 out of 100, 75, 100, 75%. There's number 1. Now, on the warm-up, I didn't ask you to give me all 3. I'm just going over all 3 as a review. Let's try example B here. The probability of picking a dime here. So I have 4 nickels. So what's the probability of getting a dime? 0. 0 out of 4. In other words, it's impossible. 0.0, 0%. Think of our scale of probability from last week on our notes. Anything that's 0 is going to be an impossible event, impossible outcome. Cool? Let's see. The probability of picking a nickel. It's got 3 pennies and a nickel. We got 1 out of 4 in fraction form. In decimal, let's see, 1 divided by 4 in a decimal is going to be 0.25. Yeah, just think about, yeah, it'd be a quarter. A quarter is 1/4 of a buck, right? And this is 25%. Thank you, guys. And the probability of picking a dime. 4 dimes out of 4 dimes. 4 out of 4, which is just 1. Decimal, 1.0. Percent, 100%. What's the opposite of impossible on that scale from last week? Possible will be anything in between. That means, what's that word that's going to happen for sure, without a doubt? Starts with a C. Certain. So this is certain. This is a certain event. You pick a dime from a bag full of dimes. It's certain you're going to pick a dime. Okay. Okay. So have some space in your warm. Let's go over another example here. That was A, B, C, and D. Let's try. Yeah. There's your table talk here. Here's your next one. All right. Go ahead and write this down as number 2 on your warm-up. If you toss 2 coins, what's the probability P that both are heads? All right, so let's think of the 4 possibilities here. The first coin, I'm going to draw the sample space. In other words, I'm going to show all the possible outcomes. So we can have the first coin heads and the second coin heads. We can have the first coin tails and the second coin heads. Right? What's another possibility? We can go the first coin heads and then the second coin tails. And then the last case, first coin tails, second coin tails. So there's our sample space. The list is like either a picture, numbers, letters, something to communicate all the possible outcomes. It could be symbols. It's just these are the possible outcomes. 4 possible outcomes. No more, no less. Now, the probability that both are heads. Okay, so let's write our formula now. Here we go. So the probability, look in parentheses now. I'm going to put just H and H, 2 heads. What's the probability of 2 heads? Well, let's see. That's going to be favorable over total. I'm abbreviating now. So the probability of both being heads is going to equal to how many favorable outcomes out of the 4 are both heads? 1 right here. So 1 out of 4. In fraction form, 0.25 in decimal, or in percent, 25%. So you have 2 coins, there's a 25% chance of them both being heads. Martin, let me talk, buddy. Thanks. Okay, 1 out of 4. Question on this one. So what enabled me to do this one is actually drawing out the sample space, drawing out the possible outcomes. This way it's clear in my head. I can see exactly what are the favorable outcomes out of the total outcomes instead of trying to do it in my head. Some of you can do this in your head, knock yourself out. But you make yourself more prone to mistakes if you don't draw out the sample space. But if you're confident enough to do this in your mind, all the possibilities, and you could see it in your mind, knock yourself out. Question number 3. Let's do this one here. This will be number 3. But go ahead and, we're not going to do the odds in this class. We're not going to focus on odds. We're just going to focus on probability. Go ahead and write this one down. This will be a last example here. You buy 5 raffle tickets. What is the probability that you will win if 400 tickets were sold? Want to copy that down first? Yeah. So it's a raffle. So the probability of winning, so I'll put a probability of winning. It's favorable tickets over total. Okay? So we're going to express the probability as a percent, decimal, and a fraction. Because we know they all mean the same thing. Just like Michael Jordan is referred to as Air Jordan, Michael, MJ, and all that jazz. We went over that 2 weeks ago. So they all mean the same thing. So the probability of winning, so there's 400 raffle tickets sold. You have 5. That's a no-brainer. Sweet. There's your fraction. You're done, in a sense. We can actually reduce this fraction, though. In other words, it's mathematical bad manners to leave a fraction unsimplified. You got to simplify it. It's kind of like burping at the table, chewing with your mouth open, or farting at the table. That's bad manners. So even though technically we're done, we got to reduce the fraction. And reducing fractions is something you guys learned way back in elementary school. If you forgot, just pay attention. 5 over 400. Let's see. Reducing a fraction involves factoring out the common factor between 5 and 400. In other words, what number fits into 5 and 400? That's the same. Right. In other words, 5 fits into both. So if 5 fits into 5 and 5 fits into 400, so I'm going to reduce the fraction. So that's going to be 1 over 80, you said, Hernandez? Awesome. Thank you. Appreciate that. 1 over 80. There's a probability. In other words, you'll win once out of every 80 tries if you had 5 tickets. You'll win once out of every 80 tries that they pick tickets. So it's not probable. I mean, it's not likely, but it's possible. It's possible for you to win the raffle. But now that's a fraction. Let's express this now as a decimal. Hernandez, can you give me 1 divided by 80 real quick on your calculator? 1 divided by 80? 1 divided by 80. Okay, watch this. 0.0125 as a decimal. So all I did is took this divided by that. As a decimal, it's 0.0125. Now, what the heck does this mean? On assignment 2, when you're doing probability and it asks for a decimal, just round to the nearest hundredth for now. So this is the tens place. I'm looking at my poster there of fraction places, or decimal places. This is the hundredths place, this is the thousandths, this is the 10,000ths. So what this really means is, look, out of every 10,000 tries, you'll win 125 times. Which is the same thing as saying out of every 80 tries, you'll win once out of every 80 tries. But as a decimal, it really means out of every, there's tens, 100,000, yeah, out of every 10,000 tries, you'll win 125 times if you had 5 raffle tickets out of 400 that were sold. But what I'm going to do right now is I'm just going to round it to the nearest hundredth. So here's a hundredths place. That 1, I look to the right of the 1. Is that number 5 or bigger? It is not. So my final approximate decimal is 0.01. I'm just rounding to the nearest hundredth for now. So here's my decimal. So I got the fraction 1 under 80, the decimal 0.01, rounded to the nearest hundredth. But you need to know that it was really 0.0125, which means 125 successes out of 10,000 attempts. This is the 10,000ths place here. See, this is the hundredths place. This is the thousandths place. And this is the 10,000ths place. Imagine a fraction that's 10,000 pieces small, like just every piece of 10,000th. That's why it gets smaller and smaller. I rounded this decimal to the nearest hundredths place, 0.01, because look at the 2 is not 5 or bigger, so I just run it to nearest. So here's your fraction of winning the raffle. Here's your decimal of winning the raffle. Let's express it now as a percent. Okay, what does a percent mean literally? Something out of what? Out of 100. So, Murillo? Yeah, right here. So the hundredths place is that second decimal right here. A fraction means something out of 100, so I'm just going to round to the nearest. I'm just looking at that number and putting it over 100. So as a percent, it's just 1%. There's a 1% chance. Tens, hundredths, what does percent mean? It means out of 100. So just take that number and put it over 100. So it's 1%. So here's you winning the raffle as a percentage. You got a 1% chance. You win in the raffle as a decimal, still 1%. It's 1 out of 100. Or 125 out of 10,000. And then as a fraction, 1 out of 80. What do you think, Gallegos? You think you'll win? That was awesome, Gallegos. Thank you so much. All right. Any questions? I'm going to be walking around to help. If this is still here.